Hello everyone. Now I will continue my project in converting a gas producer well to CO2 injection well. So now I will create the second well from the same field, but actually I don't have the original model for it. So the quickest way to do that is I just copy the first well model, and then I will just do some modifications as per the data, the configuration of the second well. All right, the productivity or the injectivity, the well bore configuration, I will change this second well, and hopefully I can get a representative result. Okay, so yeah, this is the first model. I copy and then I rename to the second well. So let's check. Okay, right, this is the name of my well, KNG second, KNG2 CO2 injection well, retrograde condensate, equation of state, okay, prosper internal equation of state model, tubing flow, injector, improved approximation, okay, convert from gas producer well to CO2 injector, okay, click done. Okay, and as per model for the second, the first well, so I create a compositional PVT with the composition 100% CO2. This is the critical temperature, critical pressure, and others. Okay, here I use Peng Robinson, and here flash straight to stock tank, correct CO2 density, yes, click OK. And this is the phase envelope, okay. Okay, so now I will change a little bit this one, the configuration or the IPR section of the second well. It will be different from that of the first well. So actually, I already have the well flow model for it for the second well, and let me check a little bit. So this is the well flow model for KNG2 well. Okay, check the IPR section. Okay, this is the reservoir section. Okay, I will get my IPR data from this second well model in well flow. Okay, so this one, back pressure method, the IPR, the C coefficient is 0.0027. And this one, exponent and exponent 0.5. Okay, so that the absolute open flow is only 2 mmscf per day. So I will copy the N, copy, and then go back to the prosper 0.5. Here, the C is in MSCF per day per PSI squared, whereas in well flow, this is in MMSCF. Okay, so I will copy this first in MMSCF and then paste it here, but I will multiply this number with 1000 because the well flow use MMSCF, or I can just change it here maybe. Okay, cannot. So here, 1, 2, so it should be 2.7 in MSCF per day per PSI squared. But the condition is the reservoir pressure for the second well is this one in PSIA, but here in PSIG, so I will change this one to PSIG. Okay, 750, the same. Reservoir temperature, I think we can use this one, 212 instead of 220. Water gas ratio here 0. Total GOR should be infinite, okay, infinity, but here I can just use 1 million SCF per STB. Okay, so far so good. Calculate. Of course, we will have issue regarding this total GOR. Okay, so the AOF for injection is the same with the previous one. It is 2,991 mmSCF per day. It's, it's huge. So practically, if you increase the pressure, the injection pressure, then you will get increased injection rate. Okay. So if we inject at bottom hole pressure of replot 1,200, I can get very high injection rate based on this IPR. But of course, the final result, final injection result will be determined by nodal analysis instead of only the IPR. Okay, so at least we have completed this section with correct CNN value. Click done. Okay, I will save. And then this one I will change the deviation survey. Okay, click injected fluid. Okay, 68. Click edit. Okay, so for KNG1, it is a vertical well with well bottom at 4,500. Now I will check for the second well. In well flow, we will have here in the deviation. Okay, so it's the same. It's also vertical well, but the bottom is at 5,000. Okay, so 5,000. I will change it to 5,000. Okay, it's vertical. So if you click plot, all right, vertical well, click finish, click done. Now we are going into this equipment data section. Okay, it's easy. The casing at 4,500. Now we will check the equipment in well flow. So the end of tubing will be located at 4,577 with internal diameter is 2.441. Okay, go back to Prosper. The end of tubing will be located at this one, 4,577. Casing will be located at 5,000. Okay, should be 5,000. And the tubing inside diameter is 2.441. Okay, casing ID. I will check the casing ID from tubing casing. Casing ID is this one, 4.995. So it's 4.995 should be this one. Okay, go back to well flow. Okay, we can check this. We can use this absolute roughness 0.0012. Go back to Prosper. Okay, let's check for tubing. Absolute roughness 0.0012. I will use that to increase the roughness. Okay, more conservative. Okay, so end of tubing already. Okay, well bottom. Okay, click done. All right, now the temperature. Okay, let's check what we have in well flow temperature model. Surrounding temperature, this one. Okay, so in well flow, the well modeler decided to just calculate instead of inputting any data. Yeah, because they have in reservoir depth, it is 220, just like we have in reservoir section, right? 220. So here, I will use this one, 5,000 with reservoir temperature of 212. Okay, so click done. Summary if you want to know. Drawdown hole. Okay. Christmas tree at 0, tubing inside diameter 0, 2.441 with this one, end of tubing, and casing ID 4.99, and well bottom at 5,000. Okay, click done, click done, click done. Don't forget to save. Okay, and the main thing that we want is actually the gradient. All right, and let's say the first node pressure is again 1,200, water gas ratio 0. Okay, total GOR. Okay, just use a default number. Okay, to describe that the total GOR is infinite. It's it's not about GOR. That's the way we say that it's infinite. We don't have a, a- an exact number for that, okay, because it's a gas reservoir, right? It's all gas, no oil. So basically the GOR is infinite. And then inlet fluid temperature 68, gas rate, we will create cases, and we have this seven seven scenarios of injection rate. Okay, click done. Again, I will use here, I use petroleum experts. Okay, what will happen if I change it to Bex and Brill? Okay, I read in some papers they use Bex and Brill. Calculate. All right. Okay. So basically for this one, I will have this one, this strand. Okay. And then this one. Oh, the gradient is high. Okay. It's even heavier than, you know, heavier than water, the pressure gradient. So certainly it will be in liquid form. This one, this one. Okay. All right. Inactive. Okay, so basically I will save this one. Okay, go back to the calculation. Not VLP, sorry. Not VLP, but gradient. Because I will copy this result pressure and temperature and plot it at my phase diagram. Okay, let me go to my phase diagram. Okay, so yeah, this is my simple phase diagram. So this line is actually the phase diagram line. Above this line, we will have liquid. And here we will have supercritical zone. And below this line, we will have gas. Okay, the first well from wellhead down to bottom hole, we will be at this zone, at supercritical zone. Okay, so it's safe because we want to inject the CO2 in supercritical form throughout the operation. And let's say I want to do that also for second well. Okay, and then go back to my Prosper, copy, and then paste it here. Okay, I want to delete this one because it's the same, redundant. We'll copy this this one. Okay, so what happened? It's here. And this one. Oh, it's should be the other way around. It's temperature and pressure. Okay. So this is the result for second well. If I plot for the first well, new well 1, temperature axis and then pressure in y-axis. Okay, so I will make this. Okay, this should be temperature in Fahrenheit, and then this one, what's the unit? PSIG. Pressure, injection pressure, or pressure in only pressure in PSIG. Okay, all right, and then I will make the legend. This is the envelope, and then this one, well 2. Okay, okay, basically I'm done. So backsand braille okay, can be used. But what will happen if I just change it to petroleum experts, the proprietary correlation created by PETEX? Okay, yeah, more or less. Not more or less, because here the gradient is much lower, much smaller. So it is more like oil. I think it is more reasonable. Okay, the tubing gradient in here. Okay, I will check the case. I prefer case 4. Okay, so I will, yeah, the gradient is 0.3. It's like oil, as heavy as oil. So I will use this one, and then I will move this one. I will, okay. I should not cut and paste, but copy and paste instead, like this. Okay, all right. I want to just some modification like this. Okay. Yeah, okay. Just small discrepancy here. Okay, but it's not a big deal. I think we can use this one. I just I'm just curious with the IPR VLP, what will happen if I inject with wellhead injection pressure is of 1200 and then I use Bex and Brill or maybe petroleum experts. Okay, this one calculate what will happen. I can inject at 7.39, but I need to be concentrate. Oh, it's difficult looking at this plot. So I will go here instead. Okay. All right. Okay, I will erase the test data because it's not relevant anymore. The test data is the production, and of course, injection and production is really different. Can I delete it? Okay. Yeah, basically, it will be like this. So it's the IPR and it's the VLP. Replot. Okay. And later on we can change this one. Okay, 7.3 mmSCF per day to ton per day. Okay. Yeah, let's say I want to use 7.5 instead. Do I have the result for 7.5 cases? I should add 7.5 here. 7.5, 10, 12.5, 15, and 20. Click done. Now I have 8 combination. Calculate. Okay, I want to get the result for case 4. Here we go. Okay, and yeah, don't forget if you want to get the whole plots, check the plot, uncheck this one, and then I only have 8 combination. Click done like this. Okay, click finish. Go to combination 4. I want to copy the pressure and temperature and then paste them in well 2 like this. Move the pressure like this. Get rid of these two because they are the same. All right. So the bottom hole injection pressure is 2,800. Okay. All right. Okay. So basically, this is the result, the gradient, the gradient, this one, the gradient or traverse for CO2 injection well. Okay. So by injecting at wellhead injection pressure of 102,000, I can maintain supercritical condition across the well, from wellhead down to the bottom hole and entering the reservoir. Now I need to create 2 more wells from another field. Okay, so I will just pause here and then, yeah, go back to create another one. Okay.